Hi, I'm Gabriel Bassett. I'm the lead data scientist for the 2018 Verizon Data Breach Investigations Report, and today we're going to be looking at a new web app that we use on our team for coding incidents from things like a PDF incident report into our normalized VERIS schema. This web app is in kind of a late alpha stage, and we're currently starting to beta test it. However, the team's been using it for several months without too many issues. And so this trains to just give an idea how we do this conversion. And this isn't going to cover everything that we do. It's not going to cover every kind of incident that's common, but hopefully it gives you an idea of what you need to hit and what you don't. Now, the first thing we need to talk about is the schema. The schema has a couple different portions. There's the schema, the actual schema you use, or the version of VERIS is what you could say. There's a version number, and then there's a file. You can load files in here by clicking load and then selecting the file. And then from there you want to select the schema. VERIS community is the base schema with nothing added. VCDB is the schema we use for coding in all of our VCDB incidents. And DBIR is basically the VCDB schema, except that it has the description changed to say DBIR, and it doesn't default to VCDB in the source ID field. That's really the only difference between the DBIR schema and the VCDB schema. The main reason we have a separate way of choosing it is because it changes how things are ordered. When you choose VCDB and hit apply, you'll notice that a few things disappear and things like the GitHub reference appear. Now, this doesn't change the underlying data in any way, but for things like VCDB, we store the number of the incident as a GitHub issue. And so we'll put that GitHub issue number here. Because that doesn't apply to other partners or other sources, we don't need it in DBIR. And so if you're starting out, I'd recommend using DBIR other with the VCDB schema, which you can download from our GitHub. Also, if you have your own schema, you can load it in here and then choose other, and it will load up, but it won't have any of this nice ordering. And so you see VERIS community is not ordered, it's just an alphabetical order. And so this is why we use DBIR. And so we'll apply the DBIR schema, and we'll get started with our analysis. First thing we want to do is enter our basic information. I've blocked out the personal information on this, so we'll just call the investigator for this incident Joe. And I'm the analyst coding it, so I'm Gabe. We can look over here and attack, this is an incident. And the reference for this will say, there's no reference number on it, but if we had a incident ID number or a case ID or something, or a URL that we were referencing, we would put it in here. Particularly for VCDB, we put URLs in the reference field. For the summary, we're going to just type up the summary as it was dictated over here. And so it's just, need to make sure it's selected. It's just an SSH server and a myPHP admin system that were compromised as part of this CCDC. And you'll notice that I blocked out the IP address. It's very important for us on the DBIR team to remove identifying information. We want all of our incidents anonymized. That may not apply to you, but it's very important for us because we're doing aggregate analysis, and we don't need anything that could identify the victims. That's not our goal. Also, I don't really need the time because we're going to code that in a different section. And so we'll go on, and we'll call the source CCDC. No campaign, and our confidence is high. And we're going to start with the incident timeline. And we'll start with just the date and time the incident was of the incident. And this is really whatever the timestamp is you have for when you worked the incident. So 2017, 4/1, 9:20 a.m. And you'll notice that some of the fields have a star by them. Starred fields are required. And so if you don't put in a year here, you'll get an error when trying to save this. However, other things like month, day, and time aren't required. In fact, we normally get year. A lot of times we get month. We sometimes get day. We almost never get time. And it's okay. You're mainly going to be doing high-level analysis, and so things as detailed as the time really don't matter. And so let's look at compromise. Well, we can look at what kind of happened, and we read through and kind of look at the description and describe it as starting with kind of a PHP backdoor. And so that kind of makes us think that this probably took the attacker minutes to compromise, but we really don't know how many. We know that it took then hours to discover because the incident was worked on May 1st, but it happened at 1 o'clock on March 31st. So let's call that 20 hours. And then containment happened in about 20 minutes because we can look up and they say the incident was closed at 9:20 or at 9:40. It started at 9:20. And containment took minutes, 20 specifically. And notification would be if this was a public breach where they had to notify people that the breach occurred to get an idea of the lag between the breach and when it occurred. Also, we skipped exfiltration. And the reason is because there's nothing in here that says that data was exfiltrated, that there was a breach of any data. It is better in VERIS to leave something empty than it is to fill it in. You know, statistically, for our purposes, leaving it empty is exactly the same as choosing unknown. And it's much better to leave it empty because things that are left empty are much more likely to validate at the end. So we'll close down the timeline and we'll go and fill in the victim. Normally we don't fill in the victim idea unless it's a public incident, just because we don't want to identify victims. But we could say this is the CCDC team. Employee count, we'll say it's a small team of 1 to 10 people. There's a lot of fields in VERIS like Fortune 500 that we rarely use. They're there if you can fill them in. But if it's something that you don't have, it's better just not to fill it in. Now, the industry is something that is important to a lot of people. And so we'll go over and we'll look at Far Smarter Biz to figure out what the industry is of a college. It looks like it's 911310, and we want to use the most detailed version of it. And so we'll fill that in here. Oh, that should be 611, I think. And then the number of locations affected is 1. The country, and you'll notice the country is required, just like industry, is the US. And the region, which is a concatenation of UNM49 regions, you could go look this up, but it's easier just to look down here in the list. This is the majority of what you'll be putting in. 019021. If you don't know what it is, you can fill in just all zeros or leave it empty. And then state, I don't know what state this took place in, so we'll skip it. Secondary victims, I don't know of any, and I don't know what the revenue is of this CCDC team, so I'll just skip it. And that's okay. Now we want to look at the actions. We'll start with the hacking actions, because it seems like this started with the remote file inclusion, which dropped the PHP backdoor. But there was also the use of that backdoor, and so we'll select that too. And that's one of the things about these fields is you can select multiple things at the same time. Whoop. You can select them if you hit the right button. So we'll go up here and find RFI again. Select it, make sure that use of backdoor is selected, and this came through the vector of the web application. And I would say that since they obtained root, based on the description down here, where did they say that? Root was obtained. There we are. We'll say that this was used to infiltrate, but also elevate in this step. And we can note that this was a PHP myadmin vulnerability that was utilized. But because they dropped that backdoor, we also want to select that from a malware standpoint. So we'll select backdoor, and this was a direct install. And this was just used to, we'll say, infiltrate. And this incident doesn't have any social characteristics. It's not phishing or business email compromise. It also doesn't have any errors. Very common errors for us are disposal errors where someone throws away PII, or another good example are publishing errors where someone puts like a spreadsheet of personal information on a public website. But we don't have any of those. Misuse is using legitimate accesses inappropriately. And so this could be mailing yourself a spreadsheet to your personal address. And it doesn't have to be malicious. It just has to be misuse of those privileges. But it could also be stealing healthcare records that you have access to for the purpose of committing fraud. Finally, we have physical, which is like laptop thefts and things like that, and environmental in case you have a breach due to an earthquake. So we'll get that filled in. We'll close down the action, and we'll go on to the asset. And so we'll look in here, and I think in the assets section, up near the top, I believe it was a list of the number of assets compromised, 2 assets. And based off the descriptions down here, it sounds like one was a web server that had the PHP myadmin install. I think it was, in fact, the Jenkins server. And the second was, we'll say one of those. And the second asset was a Elk stack, so a database server. So we'll find database in here, and we'll categorize one of those. And it says both are running Linux. So we go in, and these were owned by the victim. Cloud is really useful to fill in if you know it. But a lot of times you simply don't know what it is. But it's one of those things that people are always asking about. And so if you get the chance to fill it in, do, but don't fill it in if you don't have any information. These were victim governed. And then hosting management and accessibility tend to kind of overlap. And we'll probably combine them in a future version of VERIS. So we're going to skip those for now. And we know that the assets are all located in the US because this is a CCDC. So we'll scroll down to US, select it, and we have coded up the assets. And finally, the attributes that were compromised. And so if this were a breach, we would select yes for data disclosure for confidentiality. In fact, selecting yes here is what determines whether this is categorized as a breach or not for the DBIR. But we don't have any information that any data was compromised. If we did, we could select its type and the amount and add up here as well as totals and victims and such. But because we don't have that, we're going to leave this empty and we're going to close confidentiality. Instead, we know that the integrity of the system was infected. And so we'll look for, I think, modified configuration for the added SSH keys. And we'll also choose software installation because the PHP shell was installed. And we can note that here. It's important to understand that the notes are rarely ever going to be parsed from an analysis standpoint. But where they are useful is if someone is going back trying to understand why the record is the way it is, the notes are very useful in understanding the record. Now, a final thing we want to list is availability, because we look up at the top and it says that they had a 15-minute downtime. And so they had a loss of availability for 15 minutes. And we can put that in here. And with that, we've wrapped up the attributes section. Was this a targeted attack? It was targeted because the red team was going after them. And then we don't really know how it was discovered. Nothing in the report says that. But we know it's an insider. And so we're going to put internal unknown. And you'll notice in here that there's other and unknown. And that's very common throughout the schema. Other means that it was an enumeration but that you knew, but that wasn't listed. And so if, a behavioral tool was what detected it, but that wasn't listed here, you could choose internal other. But if you know it was internal, but you really don't know any more information than that, you choose unknown to indicate there's no additional information. And this doesn't really list the impact. In theory, we could choose something like insignificant, but in practicality, we don't know what the attackers did with the access they have. It's not written up in the incident. And so we're going to skip over the impact section, even though that's, again, one of the things that many people would like to know more about is what was lost, what varieties it was, what was the amount that was lost. but it's simply not in the report, and it's simply not in a lot of reports. Finally, we're going to go into the plus section. This is just kind of extra stuff. And most of this isn't going to matter. Most of the important stuff that gets stored in the plus section has been prioritized in this list to make it easier to fill out. But one thing that is important is the event chain. And this helps us understand what order things happen in. And so this started with the hacking action from the external attacker to hack the web app server that compromised integrity. And we could say that. PHP shell. And then we want to add our next step, which was the malware action, kind of the install of the malware, external actor, on the same server. You should say PHP shell on web app, attribute, integrity, and this is install the shell. And for distinction, maybe we set PHP shell here and we'll say exploit PHP vulnerability. And then finally, we have the third hacking action, which was external asset. This is the server, but this would be the elk stack. And this is integrity, and this is add SSH keys to elk server. And I think the web server too. Then we can go down, and most of this rest of this stuff is really not important. We have a section for PCI, but we rarely get it collected in our data. If you know the maturity of the organization, you can fill that in here, but we don't in this case. And so we'll close up the plus section and come down to the bottom. And the final thing you want to do is choose the analysis status. For us, if you're still filling things in, if you save it halfway through and come back, you want to choose in progress. After that, the first status is needs review. It's been completed, but someone needs to look at it. Once it's been looked at once, it goes to first pass for us. Once it's been looked at a second time, we move it to validated. And we will import data that's validated, but what we really want to do is have a third person look at all the data all together in a single context, and when that happens, it goes to finalize. And if for any reason it's not eligible to be in the data set, it's incomplete, or it has something else that sticks out, we can mark it ineligible. But in this case, we're going to mark it as needs review, and then we're going to save it. And what we're going to see is we're actually going to get a validation error. This record is not a valid VERIS record yet. And the reason is we didn't fill in the actors section. And so that's one of the things that's built into the tool, is to validate the record against the schema. And so we'll go back down to actor, and that we forgot. We'll say this is, we'll call the red team an activist. Maybe motivated by fun. We know that they were across in another room, so we'll just say they were in the US. And scroll down. The same region as before. And then we'll add a name of red team. Oh. And now that we filled that in, we can go back and validate it. We didn't have an internal actor. We didn't have a partner actor. And this is for when your partner is the actual malicious group, not when a partner was breached as a stepping stone to the main target of the breach. And you can find out about a lot of these characteristics by clicking more info. It'll open up another tab with detailed information about that VERIS enumeration. So we'll close back down actor, and this time we'll save it. And it shows us this is the incident as stored in JSON, the full incident we just created. And when we return, it's going to show up here in our incidents list. And when we click it, it will fill back in here. And so if we wanted to update something here, maybe fix the typo here, we can do that. And we can save it again. And so once you've done several incidents, or you're ready to export your incidents, you can select those incidents and click export. And it'll offer you to save a incident file. And now you have a zip file that has one or more incidents that were stored here. And after you save it, it's going to put it in the archive list. This is so that it's just kind of a double check to make sure you don't accidentally delete incidents that you meant to. You can always re-export here, or when this list gets too long, you can just clear it. The same way you can clear the incidents up here. And it will give you a new incident over here by clicking new. Or if you wanted to go back and edit incidents that you've previously done, you just select the JSON, you click import, select the JSON, and they will populate here, and then you could select them and edit them. And that's really all it is. And that's all it takes to create a DBIR VERIS incident. From here, you can either submit the data to the DBIR, or you can analyze it yourself using all the VERIS tools that we made online publicly for free. And so with that, thank you for watching. I appreciate your time, and I look forward to seeing the incidents that you code. Thank you very much.